Just want to say thank you for that.
Oh, you're very welcome. Now, today we will go over, give me a second. Today we will go over, let me read from my discussion board first. Don't forget that this weekend you have a quiz due. And today I will do the rest of Fall 18 Test 1. I would like you to work on the rest of Spring 16 Test 1. The files are here, but if you go back to our discussion on Tuesday, it was on our discussion board also. Yeah, so on Tuesday, actually not Tuesday, last week. My bad. Last week. So on the 16th, last Thursday, I went over number 1 to number 9 from these two test ones. Okay, these are the notes, and you can see the recording also. Okay, now so today I will do the rest for only one of them, from Fall 18 only. And then I would like you to do this Spring 16, number 10 and on during this weekend. And on Tuesday next week, then I will work on that Spring 16 one. Basically, I want you to have that hands-on experience first. Now, if you look at the videos, I have down here. Okay, one of them I went over quiz 2, 3, 4 from last semester, and I did test 1 review there, and this is the blank file, Winter 21, test 1. Okay, that's the file. So actually, at this moment, you already have one full review from my old test from Winter 21. Okay, by the end of today, you have another full review from Fall 18. On Tuesday next week, you have another one full review from test 1 from Spring 16. Okay, so basically by the end of next week, you already have 3 full review of test 1 for this course. You see what I mean? Then therefore, I really hope your test 1 is at the 90s level. Okay, at the 90s level. Now, let's start. I would like to remind you, when you study from my old test, take a look on the time. The number of points for that question also represent the number of minutes you should spend on that question. So for example, number 10 here, we did number 1 to number 9 last time, right? For last week. Okay. So the number of points for that question tells you the maximum number of minutes you should spend for that question. Okay. So number 10, 11 points. So you should take no more than 11 minutes to do this problem. Most of the time, if you get used to it, it should be a lot less. Okay, so the first number, you see this 5, 3, 3 here. So 11 points for number 10. 5 is for part A. So part A takes at most 5 minutes. Part B at most 3 minutes. Part C at most 3 minutes. Okay, so if it takes you more than 5 minutes for part A, for example, then ask yourself what slows you down. Not only getting it right, but getting it right at the proper time. Okay. I give you 2 hours for my test, which is 120 minutes. And the total points for this test is 105 minutes. So speaking, if you really take all the time that you need, you will take only 105 minutes. You still have extra 15 minutes to think a bit further for some questions. Okay, but of course, most of the time, you don't need that much. Like for example, when I ask you the range here, you don't need 1 minute to that. You just know, so range is like what? The maximum minus the minimum. Boom. Like it's not even 30 seconds. You see what I mean? Okay. And for example, number 6 here, create frequency distribution. It's like 3 or 4 minutes is done. If you really know what to do. Okay. But Thomas, then can I use that time to see from my notes? Yeah, you can, but at the same time, if you always need to see your notes, then you end up spending more time looking at the notes. Okay, the one that takes you almost really 11 minutes is number 8. But as I know, for the rest of these tests, other questions, none of them actually takes up to that number. Like number part A here, It takes like only 3 minutes, at most 4 minutes for this. Part B, maybe 2 minutes, part C, 2 minutes, and so on and so forth. Okay, so pay attention to your time. Okay, pay attention to your time. Don't spend too much time. If you spend too much time, then ask yourself what you did wrong. Okay, now let's start. Number 10, part A, a group chosen for a medical study in a college contains 70 participants with 20 smokers among them. There are 36 female participants and 5 of them smoke. Now construct a Venn diagram. Venn diagram always start with a rectangle. Okay, how do we know that we need to start with rectangle? Because the person named Venn says so. Okay, so if you don't start with the rectangle, call that Arjuno's diagram. Or call that other name. But when we call Venn diagram, then do it his way. Okay, it start with a rectangle. I know you'd handwrite yours most of the time. So your rectangle may not be perfect, but definitely not like a circle. No. Okay, try your best to make it rectangle. Okay, if you do it by hand, I think it is very acceptable to make your rectangle like that, right? I will not complain. It looks like a rectangle, right? Okay, but you need to have that rectangle. Then there are 2 groups there. First one, the group of smokers. In my class, I have a lot of examples using smokers. Okay, but I hope you don't need to think that I don't like smokers. I myself don't smoke, but doesn't mean I hate smokers. No. Okay, I just choose not to smoke. My dad was a smoker, but no longer. My brother was a smoker, had a cancer, nose cancer, and he stopped. And now he smokes again. His nose cancer has nothing to do with, I would love to tell him to stop smoking and use that cancer as a reason for him to smoke. But his doctor did say, no, it's not because of the smoking. You know, it's independent of you smoke or not. Okay, for this cancer, maybe other cancer. Okay, but for that nasopharyngeal carcinoma, no, it's not because of smoking. My father-in-law, very, very nice person, he smokes heavily. Okay, so I use smokers only as an example, not in any way against those people. Okay, now let's put this into Venn diagram. When we do Venn diagram, okay, start from the innermost one. So how many people who are smokers and female?
5.
5, okay, then I put 5 here. Okay, now how many smokers, by the way?
Well, 5 of them are female, but it says 24 are among all the participants.
So there are 24 smokers. So in this circle, there should be 24. 5 of them female. How many of them not female? Should be 19. Does it make sense?
Yeah.
Now then, among how many females we have?
36.
36. 5 of them smokes. Then how many not smoking?
31.
31. Now don't forget one last thing. They said that there are 70 participants. It means there should be 70 people in this Venn diagram. Okay, how many we have so far?
55.
So outside of that is 15. Who are these 15? How do you describe this 15, by the way?
Maybe they're the ones who like sometimes smoke, but not.
Oh, no. Sometimes smoke, still smokers. Okay, this 15
non-smokers.
You are right. You're right. So this 15 is outside of the female and also outside of smokers, right? So these 15 are male non-smokers. You're correct. Okay, so here's the thing. Why I train you guys a lot on Venn diagram, because Venn diagrams enable us to see how these numbers interact. Okay, they are not just numbers, but they have relation. Now, the thing is, when I taught Venn diagram, a lot of students actually put it this way. They put 5 here. So the following is wrong. They put 5 here, they put 24 here, and then they put 36 here. Okay, and because 70 people, they put 70 here. See, but no, this means you have so many people, more than 70 people in this Venn diagram. Okay, now some of them also did this when they did the circles. They did the circle this way. This is for female, and this is for male. Okay, now I'm not going into political correctness thingy. In my class, I will just say either male or female. Okay, regardless it's the binary, non-binary thingy, just in my class and not intended for any political or correctness or what people think. I would just make it male or female. Okay, I agree that out there it's actually a spectrum. Okay, I agree that some people think that it is a spectrum. At times, I also think that way. Regardless, I agree with that or not, in my class, just make it easy for statistic purpose. Okay, so just for statistic purpose, no other reason, no other purpose. Okay, now, but when you do it this way, then we need to explain how about people here and how about people outside and how about those smokers, right? Because Venn diagram, if you make the Venn diagram like this, you don't have any place for smokers. Okay, but Thomas, don't you think that's right that there are some females are males? I agree. There are males that are actually have females, like how to say that there's some genetic variation that makes this person have both how to say that both genders or both sex on this person, but that case doesn't happen a lot. Okay, that's one. Most importantly, that's not what our question or information infer to. You see what I mean? Okay, let's stick with the question, basically. Let's stick with the question. Okay, let's stick with the question. Even though, however much I agree with the fact that it's a spectrum, but when it comes to medical field, they still do that category in very most of the time, unless they start saying, oh, you know what, this person have some sex variations, gender variation, I forgot what is the proper term, then they will look into that further. But when they first see you, they will first see you as male or female. When they do their statistic, they will write it as male or female. Okay, then they have other additional comments or additional category in case they have something or someone else with variation. Okay, so in my class, please just see it that way, no other intention. I get feedback before, Thomas, why you only talk about that? Because I say, well, this is quite sensitive. Not everybody accept what I will say. So when I use male, female, please understand that's for computation and statistic only. Okay. By the way, let me make this off record. Okay, so that's the Venn diagram. Let's see part B. In an experiment of selecting a participant from that group at random, write the notation. I always ask this, write the notation and compute the probability. So the notation for the probability and the value of that probability of selecting a female smoker, female and smoker. How many female and smokers in that group? Not female or smoker. I'm talking about female who smokes.
5.
Out of how many?
Out of, would it be 70?
That's correct. Okay, now, if I don't say anything about what your final answer is supposed to be, then feel free to leave it as a fraction, preferably simplified one, or as a decimal. But when you make it decimal, make it 5 decimal places. That's 0.07143. Don't forget the leading zero. I think I said it many times, right? Don't forget the leading zeros. So when I say the notation, I refer to this notation. Okay. And when I say compute, I refer to this. Does it make sense?
Yeah.
Okay. Now let's see part B. In an experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting either a male. Now the thing is, we don't use the term males there. We understand male as not female. Or non-smoker. You can simply use F and S, but put the not notation on that. Okay, so you can use this, not female or not smoker. Okay, now how many not female or not smoker? How many not female?
15 plus
15 plus
19.
That's right. And how many not smokers?
Would it be 19 plus 31 plus 15?
So the not smokers one are 31 and 15, right?
Oh yeah, sorry.
But the thing is, our 15 already counted here.
Yeah.
Okay, so we don't count that 15 anymore out of 70. So this will be, what is this, 65 over 70. In simplified fraction, that will be 13 over 14. Or in decimal, that will be 0.92857. Is it okay? Now the or means it has to satisfy either one or both of that events. Now the question becomes more difficult once we put into place the not females or not smokers. You need to see not females refers to this, or not smoker refers to this. Oops. Refers to this. Now, when it is an or, then you count it if you highlight that at least once. Okay, once you highlight it either with blue or yellow, you count it. If the question were not female and not smoker, not female and not smoker means it has to satisfy both requirements, and therefore you only pick the one that is double highlighted. So if the one here was an and, right, not female and not smoker, then the answer would be 15 over 70. Does it make sense?
Yeah.
Okay, when we say or, it means it just needs to satisfy either one of the requirements, maybe both. Okay, but when we use the word and, it means it has to satisfy both. Now, I believe in my lecture and in my supplemental lecture, I used the illustration from my parents, my mom. Remember, I once, I hope you heard that. If you watch those videos, you will hear my story say that when I was 13 or 14 years old, my mom asked me this question: what kind of girl you want to marry? And I say, I want a cute one, a rich one, a nice and smart. So imagine if I say that person has to be cute. Well, there are a lot of cute girls, right? And rich, there are a lot of rich girls, but of course, the one who are rich and cute are not that many anymore, right? And nice, there are a lot of nice girls. Some of them cute, some of them not, some of them rich, some of them not. But to have a girl that has all three are basically not, the intersection gets smaller. And smart. So my mom said that even if you find such girl, she didn't say there's no such girl, okay? But what she said is, even if you find such girl, what makes you think that girl will even look at you? That hurts so much, huh? What a mom will say that to her son, right? But my mom did say that. I remember that story very much because my mom actually taught me something very useful at that time. She said that you want that kind of girl to be your wife, to be somebody you date, okay? But how do you get that kind of girl? That's actually the bigger question. Before you expect to have that kind of girl, why don't you be that kind of person first?
That kind of person. I was going to say that. If you want to attract that type of person, you have to already be that.
Yeah. So that you know what kind of quality, what kind of effort, what kind of struggle to be that kind of person. You know. So basically, instead of asking you who will love me, how about make yourself be someone lovable? Like when people look at you, they feel comfortable. You know, when people look at you, they feel that you worth their attention, their love, their dedication. You know, that's actually the lesson I learned from my mom that I remember so well. Actually, since that conversation, I told myself, yes, if I want to have somebody with quality to be my wife, I better be somebody with that quality first. It's like not only asking what that person can offer to me, but more importantly, what I can offer to that person. When I get married, my mom actually said that to me, Thomas, I can yell at you, but I will not yell at your wife. Why? That's somebody else's daughter, you know? And I know this, my parents are not someone who actually use their hands. Okay, they are not violent, no domestic violence at home. But my mom actually remind me about that. Don't you dare lay your hand on your wife, because before her parents come to you, beat you up, I will come slap you first. That's what my mom said to me. Okay, that's somebody else's daughter who is willing to dedicate her life, the rest of her life, for you. Appreciate that. You know, that's actually some words that she gave to me on the day of me getting married. You know, so of course I remember that very well. I mean, I don't want any one of her brothers to beat me up also, right? But the most importantly, that's not love. You know, take care. Okay, you can get mad with her, but never lay your hand on her. You know, well, that's love, right? Well, too much personal story. I'm sorry. I come back here. Okay, suppose we have these numbers.
Sorry, because it's all relative. Like this is the new statistics class of 2021. This is how you teach. So fantastic. If no one's gleaning any lessons from all of this, I don't know what to say. Like
there are things that I can learn from you, and there are other things I hope you can see me through. Right.
Well, it would be boring to just sit up here and just talk about statistics all night. That would be monotonous. So,
but I still need to finish this section, this test.
Okay.
Okay, so we have these three numbers. I hope you remember once I colored it, especially, right? Okay, use proper symbols and compute the mean and standard deviation of the data. One of the big question I get when I ask this question is, Thomas, you say proper notation, proper symbol, but you don't tell us this probably is population or sample. And I say, I did tell you it's population or it's sample. Can anybody tell me where? Where did I tell you it's either it is population or sample?
With the capital N?
With the capital N. With the capital N, that's right. Capital N, that's population size. The devil is in the detail. Okay, that's how we know it's population. So the mean will be population mean, which is the sum of the data over the population size. I don't think this question is hard. Okay, as long as you memorize the formula, or at least you have that formula as your cheat sheet, right? In your cheat sheet. So 4, 5, 9, 4, 6, because we rounded to 5 decimal places. Unless otherwise stated, then your decimal should be in 5 decimal places, your final answer. Now, population variance will be the population size, the first number times the third number minus the second number squared. But don't just memorize the first, second number. Make sure you pay attention to the notation though. Okay, this is the n, that's the first number, the sum of the data, the sum of the squares of the data, right? Okay, over 37 squared. 37 times 105747 minus 1719 squared. I get 957,678 over 37 squared. That's 1369. So 957,678 divided by that number is 699.54565. But this is not the standard deviation. The standard deviation is the square root of that. That is 26.448925. So that's 3. Okay, so most students who actually knows how to do this one, the one who don't know this, they don't study, they don't even know the formula. Okay, I mean, they have cheat sheet, but they don't even write that on their cheat sheet. They open the book, there's no formula involving this. You know, so this is something you need to know at least where to find on your cheat sheet. Number 12. The following Venn diagram describes the number of elements in A, B, C, and leave your answer in decimal, which means 5 decimal places. Okay, let's find out how many elements in there. The element in the whole sample space is 17 plus 6 plus 7 plus 2 plus 4 plus 3 plus 15 plus 10. I wonder what's that. 23, 30, 39, 59, 60. Is it 64? Yeah, 64. So part A, what is the probability of selecting an element from B. That's 64 out of 64, right? And how many elements in B? The way I suggest you to show the work is 6. You write this down first, and then you compute that. You see what I mean?
Yeah.
Because I have seen these kind of cases. Students, they know what to do, but they punch something wrong on their calculator. See, this is what happened. This is what happened. This is wrong. This is wrong answer. Can you tell what's wrong?
Yeah, you did over 60.
That's right. So this question is 2 points, right? If you don't show anything, you just give me this right away. I cannot give you any point. You see, because that's a wrong answer. And I don't have any reason to give you any partial points. But Thomas, I know what to do. I don't know if you know it or not, if you get wrong answer, okay? And you don't show me your work. But if you show me the work like this, okay, if you show me the work like this, I will penalize you at most 1 point, maybe only half, because this is clearly typo. You see what I mean? I know you know what to do, you just miscompute it. So show your work, okay? Show your work. This is wrong. So I happen to make a mistake, which becomes a very good example of why I want you to show me this. Okay, even if you write 60 here, at least I know that you know where that 20 coming from, right? But if you don't show me how you get that 20, you don't show me how you get that decimal, I have no reason whatsoever to give you that partial points. In other words, for me to give you partial points, I need to see partial correct in your work. Okay, but you know me, Thomas. No, I don't know you. That's bias, by the way. That's bias. Oh, did I continue recording already? Oh, okay. Now, how about part B? The probability of getting an element who is in A and C at the same time. How many elements in A and C?
7.
Are you sure?
A and C.
Mm-hmm.
Yeah, I think so.
7 and 2. That's right.
Oh yeah, 2.
2 is also in A and C, right?
Yeah.
Okay. 7 is in A, B, and C. But there are 2 more elements also in A and C. Okay. So that's 9 over 64 in decimal is 0.14063. Part C over 64 in A or in B. So let's see the one in A, 17 plus 6 plus 7 plus 2 plus the one in B's that we have not computed. So plus what?
4 and 3.
4 and 3, that's right. So 23, 39, that's 39 over 64, which is 0.60938. Okay, let's go down further. In A and not in B. In A and at the same time, not in B. Not in B. Of these, the one that is not in B are this guy and this guy, right? Maybe I put it this way so that you can see better. The one I circle here are in A. The one I circle next are not in B. These are not in B. Because we need an and Then we need how many circles? The one double circle.
Double
Right?
circle, yeah.
The one double circle. So it will be 17 plus 2. That's 19 over 64, which is 0.29688. Supposed to be 75, but by rounding to 5 decimal places, that's what happened. Let me erase that. Okay, how about part E? It gets harder. B or not C. B or outside of C. Outside of C are these. But that's an or. That's an or. If it is an or, we just need at least one circle, right? So the one in B are 6 plus 4 plus 7 plus 3 elements, plus the one outside of B, outside of C, that's not counted yet, plus 10 plus 17. Okay. That will be what? That's 47 over 64, which is 0.73438. Am I too fast?
That's a 4, right? Not 9. I know you said for 7, 3, 4, 3.
Yes,
8.
that's a 4. Thank you.
Yeah.
It does look like 9 though.
Yeah.
Okay, now then part F, not B and not C, outside of B and outside of C. Because it's an and, how many circles should that be? It's an and, so it has to satisfy both requirements. That would be 10 plus 17. That's 0.42188. And part G, I think this is the last question from this page. Part G, not A or not C. Now, can you tell me how many elements outside of A? What number should I register?
10
Uh-huh.
and 4.
And then?
3.
And then?
15.
And then? So those are the one outside of A or outside of C. 10, but it's counted already.
Yeah.
Right?
10,
17.
17. 6.
And then?
4, but it's already counted.
So we don't add them anymore. Good.
Yeah.
Okay, so then we compute this. That's 17 plus 15, 32, 49, 55. You know what? I'm a bit tired, so I don't trust myself that much. Let me use calculator. Yeah, that's 55. So 55 over 64 is, in decimal, this will be 0.85938. Okay, that's for this question. Basically, this question asks you if you know the notation, that's first, like how do you read the probability notation, and the meaning of that notation. When we say probability, like part C, for example, probability of A union B, do you know how to count it? You know what it means, relate it to the picture and count it.
Really quick, for the last one we did say that the symbol was for and, we wouldn't have to include all of those numbers, right? We would
You're
just say,
correct. You know what?
okay.
Let's do. Why don't we just do it? So
all right.
probability of not A and not C. What will that be?
So not A or C, so it'd be 4 and 10.
Not A and not C. That's right. That's 4 plus 10.
All right. I just wanted to make sure.
4 plus 10 over 64. But you're good. 14
Okay.
over 64. This question happened to be very similar to the previous question.
Yeah.
Right.
I just wanted to make sure that like whenever it's saying or, that, and the different meanings of including it all versus not including it. So
that's right.
Thank you.
Sure. Next one. The following contingency table describes the distribution of smoking status of 150 participants based on their final education levels. First, find the total for each column and row. Basically, you need to add all of these. 37, 30, 45. This is 58. 29, 49. This is 48. 43. And then I add vertically 49 plus 48 plus 43. I get 140. So something is wrong here. Let me confirm by adding horizontally. Okay, it should give you 140 at the same time. Just in case we count anything wrong. Yes, I get 140 also. Okay. So we have high school graduate. This refers to the final education level. So the final education for high schools, there are 49 people. Final education associate degree, 48 people. Final education bachelor degree, 43 people. Okay. If a participant is randomly selected from that group, write the notation and find the probability of selecting part A, a non-smoker, probability of non-smoker, currently not smoking. Is former smoker considered a smoker? The answer is no.
No.
Okay. Because if that person is considered a smoker, then you don't need to use the word former for that smoker, right? Former smokers actually to explain this person smoked before, but currently not anymore. Okay. Former students means that person was a student, but not a student anymore. Okay. So not current. There are two ways to do this. The first way is you see how many people not currently smoking. 37 plus 58 out of 140. That's 95 over 140. Now, the thing is, you need your answer in simplified fraction. So simplify your fraction. I will teach you how to use, if you happen to have TI 83 or 84, actually other calculator also maybe have that, but you find out yourself how to do that. Like if you happen to have TI 30, I know they have it, TI 36, they have it. Let me show you how to convert this to a simplified fraction. Okay, we have 95 over 140. Is it right? If you press enter right now, it will give you decimal. Agree? But we don't want decimal, we want simplified fraction. Then how to make it into simplified fraction? You press math here, math, and the first option. This means convert to fraction. It's already a fraction though, Thomas. Yes, it is already fraction, but when you are forced that to write it in fraction, it will give you simplified fraction. Okay, it will give you simplified fraction. So that's if you want to use calculator, but actually you can just look at that and say, oh, you know what? Both of them actually multiple of 5. So on the top, I divide by 5. On the bottom, I divide by 5. You reduce the common factor. Okay. Part B, a former smoker with bachelor degrees. So former with bachelor. How many former and bachelor?
22.
That's right, that's 22. Both of them even number. When I reduce, I get 11 over 70, and that's the simplest we can go. Part C, a smoker or an associate smoker or associate. How many smokers currently smoking?
45.
Okay, plus how many associates?
21.
But that 21 already counted though.
So would it be 11 and plus 16?
Yes, you can do that. You can do that. I will do the following. I will use 48 minus the double count. But you can also use 11 plus 16 after that 45. Basically, we need to add these numbers. Okay, basically, that's what we need to add. You can just add them one by one, 11 plus 15 plus 21 plus 16 plus 9. That's also okay. Okay, now notice what I did there is basically the foundation of inclusion exclusion formula. Do you remember that? The union? The probability of A union B is probability of A plus probability of B minus the probability of the intersection. Okay, and that will be, what's that? 45, 48 minus 21. That's 72 over 140, 72 over 140, but I need to simplify that. Reduce by 4, 36, 18 over 35. Is it okay?
Yeah.
How about you, Yvette? Sonia?
I'm here. I'm right here.
Okay, are you okay?
I'm great.
Okay, good.
I have a question.
Uh-huh.
Okay, so I started to work it out on my own, but I had put never, outside of never. Instead of smoker, I had put outside of never because I'm considering that the former at one time was also a smoker,
But not currently.
but not currently.
Yeah. So the terminology non-smoker refers to that person is not currently not a smoker.
Okay.
Okay. That has this kind of issue for something else. of course, by the way, I'm not saying this in sense of being I never try to be political in my class. Okay, but I want to describe a little bit about some terminology. Okay, we have a case recently, a case in Indonesia where somebody was put in jail for his crime, and he admit his crime, so he was put in jail. He got like 2 or 3 years, I think, and then he came out. So is that person a criminal?
He paid his debt.
So is that person a criminal?
Former.
You are right. Okay, that person is no longer a criminal. I know the society still try to punish him for the mistake that he made. And yes, I agree, there's something called social punishment. Okay, but to call him a criminal is not correct anymore because he already paid for his crime. Okay, you want to treat him differently right now? Fine. Okay, but before the law, under the law, he is now already not a criminal. He paid his crime already. Now, of course, people say, but the punishment was not fair. It's supposed to be longer, supposed to be 6 years or 8 years. But by law, he already fulfilled what he needs to fulfill. Okay, I am not saying in any ways that smokers are criminal. Okay, no, that's not what I'm saying. I'm saying that when we say former smoker, it means they are no longer a smoker. Okay, former students mean former West LA College students means that person is no longer West LA College student. Therefore, there is no such thing called former mom, former dad, former child. There is something called former student, right? Okay, but there's no like, oh, that person is my former son. People will raise their eyebrows right away with that term. There's no such thing. Does it make sense? But once we use the word smoker, former, it means that person was, but no longer. Okay, I hope that explains. But that's just terminology. That's just terminology, though. That's just terminology. For students who actually use the non-smoker, they interpret that as never, I penalize them only 1 point instead of 2 points. I see their point of view, their understanding, and it has nothing to do with statistic. It's the language barrier. You know, and it happens even to a native speaker. You know, it happens even to a native speaker. I try not to use the terminologies that is hard for, especially international students, especially those whose first language is not English. You know, so my word problems tend to be a lot shorter than the one you see in the book. And I hope that's actually helpful, so that I can actually measure you, judge you only on your stats instead of your English ability, you know. But unfortunately, stats is very applicable, such that I cannot go too far from the need of using some English terminology. Okay, but I hope it's not too difficult to understand. Part D, find the probability of selecting a high school graduate but never smoked. High school graduate and never smoke.
So whenever we'd see but, we should use and, right?
That's correct.
Okay.
Mm-hmm. That's correct. So that will be over 140. But how many people actually high school but never smoke?
14.
Mm-hmm. And both of the multiple of 14 is clearly seen. So this will be 1/10. Okay. And then part E, a former smoker without bachelor degree. Former. Is it or and?
Would it be for or?
Is it for or? Does this requirement restrict this?
Yeah,
or
with and. With and.
So the idea is, does it restrict or enlarge, right?
Yeah.
It is a restricting. So, and not bachelor. Without, right? Former and not bachelor. So how many people, former smoker, and at the same time don't have bachelor degree?
+20 + 16.
20 + 16, that's right. That's 36 over 140 reduced by 4. That's what we get. Okay, again, for the reducing, you can just use your calculator also. Okay, but sometimes you stare at that, you see, oh, that's even number reduced by 2. Oh, I can reduce again by 2. Just keep doing that. Okay, now the next couple questions are the hard one. 2 participants are randomly selected from that group. Find the probability of selecting. Notice here, I don't need you to write the notation. Just give me the numbers to add, subtract, multiply, divide, maybe, and then compute the final answer. Okay, find the probability of selecting 2 participants without associate degree. How many people without associate degree? Sorry. How many people without associate degree?
49 and 43.
That's right. So, so the number of people without associate degree is 49 plus 43, that's 92. Is it right? There are 92 people without associate degree. Okay, but you need 2 of them. So the probability will be, let me write down the probability notation, both without associate. What is the probability the first one you take has no associate degree? That will be 92 over 140, right?
Yeah.
For the first person. Now, after you get this first person, what is the probability the second person also without associate degree?
91
over
139.
That's correct. Then from here, you use your calculator. Now, when you use your calculator, do it this way. You multiply across first. You can also do it this way. You basically type, I want to show you how to do that. Give me a second. So that will be 92 over 140. Continue right away. Times 91 over 139. Okay, then from there you see, oh, this 0.43022. 0.43022. What I'm trying to say is this: do not change this to decimal and then this to decimal and then multiply, because once you change that to decimal, you already have rounding error. This also have rounding error. Okay, when you multiply 2 rounded number, you have what we call compounded rounding error. Okay, the error may accumulate. That's the thing. Okay, so instead of do too many roundings, multiply all of them at once, right? And then you compute. Okay, that's for part F. Now let's see part G. At least one never smoke. At least one never smoke. Probability, at least one never smoke is equal to 1 minus probability ever smoke. Maybe I put it this way. Another way to say it. Probability at least one never smoke is 1 minus probability none of them never smoke. Does it make sense?
Yeah.
Okay. The number of people never smoke is 0. Okay. But how many people never smoke?
37.
Okay. Then how many people smoke before? Ever smoke? This. Right?
Okay.
103. There are 103 people ever smoke. Now you need to choose both of them from there. So the first one is 103 over 140 times 102 over 139. Okay, then we use our calculator. Let me just use my calculator. That's 1 minus 103 over 140 times 102 over 139. 0.46012. 0.46012. Let me finish this one question, the last one, part number 14, and then I give you an illustration. Okay, I give you an illustration. Basically, like suppose you have a deck of cards, right? You have a deck of cards and you select 3 cards. Select 3 cards. Okay, without replacement. What is the probability at least one ace? Maybe one of them ace, maybe 2 of them ace, or 3 of them ace. But that probability will be 1 minus probability that you get no ace. Does it make sense? It's easier to compute it this way. Instead of computing what is the probability of getting 1 ace plus probability of getting 2 aces plus probability of getting 3 aces. That's a lot harder.
Really quick, I think for me, where's the 1 coming from?
The complement.
Okay, I think, all right. I think
right, that's the complement. Yeah, that's the complement.
All right.
It's either, I can draw it this way. It's either this. Nobody never smoke, 1% never smoke, 2 people never smoke. The question is at least 1 never smoke. You pick 2 people, right? At least 1 never smoke. So this is 1 or 2 never smoke. That's the complement of these.
Yeah, I remember now from your illustration.
Okay, yeah. Yes, the complement thingy. Okay, so the last one, suppose probability of A is 0.57, probability of B is 0.64, and the probability of reunion 0.8. Find the probability of the intersection. Most students get this question as long as they study a little bit. And they study till the end, like the end material, which is inclusion, exclusion formula. Always write down the formula first and then plug in numbers, then you solve. Okay, I purposely use A and B, but in my other tests, I actually use C and D or other notation, a pound star, let's say. And then I plug in numbers. This is 0.8 equals to 0.57 plus 0.64 minus the one we are looking for. Then compute. Remember, when you solve an equation, this is 1.21. Your equal sign should be straight, okay? So probability of A intersection B, I add both sides by probability of A intersection B equals to 1.21 minus 0.8. Addition becomes subtraction. Okay, so probability of A intersection B therefore is 0.41. Okay, that's what we have gone so far. Let me remind you that I would like you to, I will save this and post it on our discussion board. I will post it here on our discussion board, but please don't forget on Tuesday next week, please attempt, at least try to do this so that if you have any issue, any difficulty, we found out 1 week before the test, okay? But yes, I will save it and post it here once we are done with this class. I'm 4 minutes over time. Thank you to stay with me, 3 of you, and see you on Tuesday then.
Do you have a second
you,
to go over
Professor.
something?
Repeat it again.